Last time I talked about the NLS lang setting, what to look at when you set it, and what are the problems that are associated with setting it incorrectly. If you think that you have to set NLS lang to the character set of the database, then you think wrong. It's not the right source of the setting, right? The NLS lang must agree with the operating system and actually with the data that's the text data that the database client receives. If you set the NLS lang to the same character set as the database, then you create something that we call a pass-through configuration, because there is no character set between client and server, because the client declared character set is the same as the database declared character set, so no conversion happens, which means that whatever you pass to the database client gets passed to the database and stored there. And as long as this data that the database and the client receives from is correct, I mean, is in the same character set that the database character set declaration says, everything is fine, and this is a correct configuration. But in cases where the client is actually configured for some other character set, some other language, then the bytes that get generated by the keyboard and by the client are still there, right? And they still get stored in the database, except that they are in the character set of the client, which in this case may not be the character set of the database. So if the database tries to interpret this data in any way, for example, converting it to some other client that works in Unicode, or passing it to some other database, or uppercasing, or maybe sorting, then because of this misconfiguration, the results are incorrect, even though the original application that stores the data can retrieve it and is sure that everything is fine. And there is no warning, and of course, in such case, and sometimes customers notice this issue very late, after a few years, when the database is already full of data. And then you have to kind of repair the database by correcting the declarations of the character set, or maybe some converting the data, depends, of course, on the given configuration. So this is what I discussed last time. So this is a short recap for you. Byte character corresponding to a multi-byte character. Okay. This is an interesting question. Actually, it is not documented well. So this naming is actually a bit misleading, right? Because what these functions are more about is not single byte versus multi-byte, but actually half width versus full width. And this is associated with the fact that when you process East Asian scripts, then historically, especially when this text was displayed on hardware terminals, right? Not currently in GUI, where the fonts are proportional and everything looks differently. Previously, on hardware terminals, because the ideographic characters of East Asian scripts are relatively complex, some of them, then of course they cannot be rendered on the same space as a traditional ASCII Latin letter. So each such character occupied on a screen a position, more or less 2 positions compared to an ASCII character. So this was a full width character. It was, in this way, it was kind of square. And this is how Chinese characters are normally written. They are normally put into a square, so the length and the height are more or less the same. So so sometimes when you write Chinese, you also want to mix some ASCII letters. For example, you include Oracle or some Western names that you don't want to transcribe to Chinese, or some punctuation or whatever, some citation from English. Then it looks more natural for East Asian users when these ASCII characters have the same width as the Chinese characters. So they are like wider, right? They are on a square field and not on a rectangle field as usual on a hardware terminal or even on current GUI screens. So it's why the East Asian character sets have all ASCII characters defined additionally in the so-called full width version, where the character is the same, but it is expected to be rendered as a wide character of the full width of a Chinese character. And these two functions basically are used to map from an original ASCII code to the corresponding full width code in a given character set, or the other way around. 2 single bytes goes from full width to single width, and 2 multi-byte goes from single width to double width character. Yes, I mean, so the answer to the next question is that indeed in East Asian character sets, because this is specific to Chinese and Japanese character sets, and probably Korean, I'm not quite sure here. So each character has 2 versions, indeed. I mean, lowercase a has actually 2 codes. One is lowercase a with the traditional code 60 hexadecimal, right? And the second one is full width character. Let me actually see if I can demonstrate it. So here we have a font which is a Chinese font. And here we have the normal ASCII characters, right? With Unicode codes that are numerically the same as ASCII codes, and they are single width characters, right? Let's see here, right? And then let me, I don't unfortunately remember what are the codes. Okay. And here we have a full width Latin small letter A. As you see, wider, right? If I just use the keyboard to write a normal ASCII A, it's normal width, and the character is full width. And this is important to recognize that they are, as abstract characters, they kind of the same, right? So this is Latin lowercase a, and this is Latin lowercase a. However, they have different codes, which means that in most cases where there is no special comparison rule active, they will be treated as 2 separate characters. So if you have a table name, for example, in a Chinese database, named with full width characters, which you can do, they are valid letters, right? So you can name, and you then try to reference such table using the normal ASCII codes, then you won't be able to access it. It will be treated as 2 different names. And this is actually one of the cases that is considered interesting from the security point of view for like phishing sites, right? Phishing sites, when there is always a risk that somebody can use a wide character instead of a standard width character, and in this way try to impersonate some known site like Google or whatever, Gmail, right, and steal some data. So it's why the web standards usually, or I think DNS standards forbid actually to register names that just differ by the width of the character, because they would be considered two different sites, even though a normal user seeing something like this in a URL may think that this is the same URL, right? No, this is actually different. I mean, the question is in the chat. The warning that you get is usually if you have a file that was opened as an ANSI file, right? The ANSI code page file. So this is one of the MS Win code pages, code page 1252 or 1250 or whatever, Western European, and then you edit this file and you add some characters that do not exist, because Notepad, when you write, it works in Unicode. So it will accept any Unicode character, right? Independently of what was the character set of the file. So you may add some characters that are no longer valid. Let's say you opened a Western European file, right? Or you have a Western European Windows. So, I mean, the Windows are generally American and configured for Western Europe, so they work in the ANSI code page 1252. But then you switch the keyboard to Hebrew, for example, and you put some Hebrew letters. And then when you try to save this file, then of course Notepad remembers that the original code page in which the file was opened was the ANSI code page, which was, let's say, 1252, and then it recognizes there are characters in the text that is on the screen which cannot be represented in 1252, and then it will warn you that if you want to keep those characters, you have to store the file as UTF-8 or as Unicode UTF-16. Right? You have some choices to choose from. Then the characters can be preserved, but of course the encoding of the file will be changed. So you may not want to change the encoding of the file. So either you use Unicode and you can use all characters, and or not. Right? Of course, if you will try to store a full width character in a Western European file, you will get the same warning, because this is not the full width character is not an ASCII character, so needs a Unicode you need either Unicode or some Chinese character set to be able to store such code. You normally don't enter full width characters by mistake, right? Because you need a keyboard that is configured for such characters. So basically, unless you have a Chinese or Japanese keyboard configured in your system, it's very improbable that you will actually enter any full width characters into a Notepad file, right? Unless you got this file from somewhere, for example, from East Asia, and it actually has such characters, then of course it may have some problem. But in this case, such file would be already encoded, probably either in Unicode or in the Chinese code page. If it is in a Chinese code page, that you wouldn't be able to open it on Windows that are not Chinese. Yes, the copy-paste operation, of course, from the web page, they could come. There is always a risk that if it is a web page, then some designer of this page, if this is just ASCII characters, and we are not talking about Chinese or Japanese web page, but a normal web page, there is always a risk that somebody tries to I don't know, make characters looking like more distributed on the screen, so like not condensed but expanded, right? So expanded text, and instead of using the proper CSS, style sheet information to change the font, actually abused these white characters for to get a certain graphical effect of such expanded font. It is possible. Then in such case, if you copy paste such characters, then they would be copied as these white characters, and then if you try to store them, then you may get this message. This is a theoretical possibility that I see here as a source of the problem that you may see on your computer. But exactly, I would of course have to see a somehow reproducible case that to be able to like confirm what is the most probable case, assuming it's not a bug in Notepad. But I guess it's probably not a bug in Notepad, so it may be a problem when the source of the data that you copy paste to Notepad.